Arithmetic. Arithmetic is just fancy talk for adding, subtracting, multiplying, and dividing. Think about when you have 5 pizzas and 2 friends. How do you split them equally without causing a world war over extra slices? That's arithmetic, solving everyday problems one pizza at a time. Fractions. A fraction is like a slice of pie. Imagine you have 1 apple pie and you cut it into 4 pieces. Each piece is a fraction of the whole pie. So if you grab 1 piece, you've got 1/4 of the entire pie. Easy as pie, right? Variables. In math, a variable is like a treasure chest that hides a number inside. For example, if x plus 2 equals 4, then what's x? Just like solving a mini mystery, you find out x is actually 2. Variables are the detectives of math equations, always sniffing out the missing numbers. Geometry. Geometry is the art of playing with shapes and figuring out their secrets. Imagine drawing a house without knowing any geometry. That crooked triangle roof might end up looking more like a sad pancake. Geometry helps us understand shapes, sizes, and angles, essential for everything from architecture to video games. Equations. An equation is like a seesaw. Both sides need to balance perfectly. For example, 3 plus x equals 5 needs a little x equals 2 to stay balanced. It's all about keeping things fair and square, just like when you're sharing snacks with a friend. Pi. Pi is a number that mathematicians and circle enthusiasts absolutely adore. It starts with 3.14 and goes on forever without repeating. If you've ever tried to measure the edge of a circle with a ruler, you've seen pi in action. It's the ratio of a circle's circumference to its diameter. And yes, it's as endless as your last road trip. Algebra. Algebra might sound like a country, but it's actually all about finding unknowns. For instance, if 2x equals 10, algebra tells us that x must be 5. It's like detective work, but instead of looking for clues in a mansion, we're solving for x on paper. Probability. Probability is like guessing how likely it is to rain, or whether you'll pull a blue candy from a bag. If there are 3 blue candies and 7 red ones, the probability of grabbing a blue one is 3 out of 10. It's the math behind your luck. Calculus. Calculus might sound intimidating, but it's just a way to study things that change. Like if you're watching a balloon slowly deflate, calculus helps you figure out how fast it's happening. It's the math of motion, growth, and change, perfect for when you need to predict how long your last piece of gum will last. Statistics. Statistics is all about collecting and analyzing data. Ever wondered how companies predict what you'll buy next, or how pollsters predict election outcomes? That's statistics in action, making sense of all those numbers to help make decisions. Example, if 6 out of 10 students in a class are wearing glasses, 60% of the class wears glasses. Trigonometry. Trigonometry is the branch of math that deals with angles and triangles. Ever aimed a basketball shot or adjusted a satellite dish? You were using trigonometry. It helps us understand how angles affect everything, from sports to space travel. Exponents. Exponents are like math's way of expressing really big or really small numbers. For instance, means 10 multiplied by itself, which gives us 100. It's a quick way to show how numbers can grow exponentially, like how one viral video can lead to hundreds more views. Integral. Integrals are a part of calculus that help you add up pieces to find whole areas or volumes. Think of it like trying to figure out how much paint you need to cover a curvy shape. It adds up all the little bits to give you a total. Derivative. Derivatives are another calculus concept that measure how quickly things change. If you're racing your friend on your bikes, the derivative helps calculate how quickly you're accelerating compared to them. It's like having a math superpower to predict who will shout, "I'm the king of the world!" first. Example, The derivative of x squared is 2x. At x equals 3, the rate of change is 2 times 3 equals 6. Matrix. A matrix is like a spreadsheet full of numbers. It's used in more advanced math to handle complex problems like 3D graphics and systems of equations. If you've ever seen a bunch of numbers arranged in rows and columns, that's a matrix at work, organizing data for everything from computer games to scientific research. Vector. Vectors are arrows that tell us not only how much, magnitude, but also where to, direction. Imagine you're on a treasure hunt. Vectors would show you how far to walk and in which direction to find the chest. They're essential in physics and engineering to represent forces and movements. Example, a vector pointing right with a magnitude of 5 means move 5 units to the right. Complex numbers. Complex numbers sound complicated because they have a real part and an imaginary part. Think of them as 2D numbers. If real numbers line up on a one-dimensional line, complex numbers add a whole new dimension to play with, helping solve puzzles in physics and engineering that real numbers can't handle. Example, 3 plus 4i is a complex number with a real part of 3 and an imaginary part of 4. Logarithm. A logarithm is the inverse of an exponent. It answers the question, to what power must a base number be raised to produce a certain number? For example, the logarithm base 10 of 1000 is 3, because 10 to the power of 3 equals 1000. Permutations. Permutations deal with arranging objects. If you want to know how many ways that you can arrange your 4 different action figures, permutations have the answer. It's all about options, from lining up for a race to organizing your bookshelf. Example, for 3 different action figures, A, B, and C, they can be arranged in 6 different ways, ABC, ACB, BAC, BCA, CAB, and CBA. Binomial Theorem. The binomial theorem shows us how to expand expressions that are raised to a power, like x plus y to the power of n. It's a shortcut past multiplying out the terms one by one, which can save a ton of time in exams and when dealing with algebraic expressions. Example, expanding x plus 2 to the second power results in x squared plus 4x plus 4. Conclusion, math's everywhere and more. As we've seen, math isn't just about numbers and complicated formulas. It's a tool that we use to understand the world. From baking cookies, that's fractions, to saving money, hello arithmetic. Math is your everyday companion, whether you realize it or not. So next time you see a math problem, remember, it might just be more fun than you think. And now, a quick challenge. Imagine you have a clock. The minute hand is at the 12 and the hour hand is at the 3. Over the next 15 minutes, the minute hand moves towards the 3. What angle in degrees will be between the minute hand and the hour hand at the end of these 15 minutes? Leave your answers in the comments below, and let's see who can crack this time-telling teaser.